Hello, my name is Sourodeep Kundu, and I'm going to present my project, CEO Final Lab Record project. This is part one, and in part one, I'll be covering these highlighted green text. And in the second part, I have already covered from programs 1 to 6. Let's start. Let's start with, as you can see, this is my cover screen program where all the programs are made in menu-driven format in cases based. Let's start with firstly rebuilding the solution. Let's see how's the output coming. As we can see, it's still building. Just a second. Yeah. So as we can see here, 1 succeeds, 0 failed, 0 skipped. So let's debug it. Start without debugging. Yeah. So this is the project. In here, program number 1 to 6 are already covered. Let's start with program number 7. That is all the runtime environments. Let's see the report. Yeah. Here we are getting a menu-driven program of all runtime environment routines. Let's start one by one. Here I have set OMP set number of threads. Number of threads has been set to 4 according to the program that I have written. To where we'll get the number of threads in option 2. So the number of threads is 4 each. So total there I have logical processes, 16 logical processes. So 4 into 4. So moving on, get max number of threads in the system. Let's see. So max number of threads in one is 4. Moving on, get the number of threads in option. So in thread ID we are getting 0 to 4 threads, 0, 1, 2, 3. So fifth one is get number of process. So the number of processes, as I said, the logical processes are 16. Moving on, sixth one is here the sixth is OMP in parallel. So in parallel we are able to run the program. So by thread number 1 we are getting the output. Let's go for OMP set dynamic, that is dynamic scheduling. Let's see the example. So yeah, it is set dynamic is enabled. We'll do similarly get dynamic and so on. So that's 8. The get dynamic is the flag is set to 1. Get nested. OMP nested enabled. Then let's say get nested. So get nested gives the flag value. If not enabled, then it will give 0 value. So I just enabled it, so we'll get value as 1. Let's check that. So yeah, OMP get nested 1. So let's exit from this and move on. Yeah, so this I have created a looping form, so it will start again from next option without exiting. Let's start with dynamic scheduling. Dynamic scheduling program is program number 8. Yeah, as you can see, I have getting the dynamic program as well as dynamic program with the chunk size 2 dynamic scheduling, and the threads are so on and so forth. Let's start with the guided program here. 9. This guided scheduling. You can just pause and view the output. Let's start with the last one, that is the static scheduling. This is the static scheduling output that we are getting. Let's move on to critical and reduction. Critical and reduction clause. So this is the critical clause program output, and this is the reduction clause output. Now output of the program with reduction clause. Sum of array elements is 55. So that's all. From here on, 1 to program number 6 will be later explained in the next part. Thank you. I'll just exit the code. Hello, so my name is Sourodeep, and today I'm here to present my project on the compilation of the whole codes of OpenMP programs. So this is my cover screen .h program where I have imported all the code files, and now we'll run a menu-driven program which runs all these codes. So let's start quickly. Let's build the project, rebuild solution. And as we can see, it succeeded here, and 0 failed, 0 skipped. So now let's debug, start without debugging. Here I can see the screen that we designed here. Let's start with the newer programs, then we'll go to 1, 2, and 3, the older programs, because we know how it runs. Let's start with 4. So 4 is work sharing constant section. That is the calculator problem, I guess. Yeah. So as we can see here, we have created a looping problem. That is after it's run, all the calculator problems are done. 5 plus 3, 5 minus 3, all results are given, and the execution time serial and parallel is calculated in the work sharing calculator program. Moving on, let's go to next fifth problem. That is the square of number problem. Okay, so we are getting the result for square of number problem also. As you can see, the square of each and every number is being produced here. And then the squared results are also displayed, 2 power 0, 2 power 2, 2 power. So now let's go to the next problem. That is the card game problem. Here is card game problem. Here we had used the shared private, the static guided problem. Here, as you can see, the player 1 hands are randomly shuffled and player 2 hands. So the problem is like there will be total of 26 plus 26 cards, and that is 52 cards, and each player will be randomly shuffled cards. And so every time we run this program, we'll get a different output because the randomly section wise it's been dealt. So here, as you can see, we are able to see player 1 was divided cards by dealt the cards by thread 15 and player 2 by the thread 14. So all the newer programs are over. Let's start with program number 1 next. Program number 1 is parallel serial construct. So let's do the serial one first. As you can see, we got the serial output. Let's do the parallel output. We're getting my number of logical processes are 16, so I'm getting 16 outputs, 0 to 15 threads. Let's exit this one, and yeah, I have exited. Now let's debug once more to run the second one. Here we go. Let's run the second program, and we can see execution time for serial parallel. Let's do option 1. I'm getting for serial, this is the execution time. Let's do second one. This is for parallel, and that's the execution time of parallel. Let's do for thread ID calculation for serial. Thread ID by 0, that is the master thread here. And let's go for thread ID parallel. These are the parallel thread IDs, as you can see when parallel program is done. Let's exit this, and let's run again once more. Debug start without debugging. And yeah, the last program left is the work sharing construct for. Here we have 3 options: parallel forward constructs only, that is only for, and this is parallel regions, that is section wise will divide. So let's do that. As you can see, thread ID work sharing construct starts, so it's getting into various parallel regions for various constructs. So let's exit. This is the correct output as expected. So all the codes are done. So I'll sum it up. So these were the codes, and you can just go through once the lab soft record that I had created. And thank you. This was a tutorial on how to create the final menu driven program for the lab course of COL. Thank you. That will be it.